So, welcome. Good afternoon. Thank you guys, the guys hanging into the bitter end. I like to think they saved the best for last. Find out. My name is Keith Volkert. I'm the CEO of Satellite Consulting, Inc. I have been in the aerospace industry for 52 years now. I started as a summer hire on the Apollo program in 1967. Had almost a decade at the Jet Propulsion Lab, worked on the Viking Mars mission, the 2 Voyagers that went past all the planets and went out of the solar system. And the 3rd program was the Galileo program with pictures of Jupiter and all the moons and all the good stuff we did. I left the lab, joined Communications Satellite Corporation, ComSat, for those of you in the business. Stayed with them and got my 20 years in. Retired on my birthday, formed my own company, and that was 18 years and 3 months ago. So I'm still having a lot of fun. Paper today, the discussion has a very long and probably not properly structured title. The inventory of tested and qualified space parts exist already in space. That's what we're going to talk about. So I lead you through what I'm going to talk about here. I'm going to pose 3 questions, hopefully then answer them. I'm going to tell you the source of this hardware that we think is there and ready to be used. There's a critical question, and that is a question of who owns the abandoned satellites in space, and that's a key point in this. Then, for those of you who haven't spent a lot of time in the manufacturer's high bay with the caps and the booties and stuff, I'm going to show you a few pictures with some typical configurations. Then get down to the meat and potatoes, the 5 steps involved in what I think we have to do. So we'll start with the questions. So, how can we possibly afford this? How can we afford to send all of this equipment to the moon and put it there? When I came up through the last 3-4 decades here, the number we always used, rule of thumb, was $10,000 a pound to get something to geosynchronous. And that number held for a long time. Elon, SpaceX, Falcon 9 has reduced that. Elon promised us a factor of 10. He got a factor of 3 so far. Very good. So now the rough number that I use is kind of $3,400 per pound. It's still a lot when you think about what it is we have to get to the moon. That's a lot of dollars. So then the second question I pose is there an existing source of this hardware already in space? And I've already given you the secret, so it's not much of a question. The answer is yes. There's an awful lot of stuff that can be salvaged from the geosynchronous arc. And then the third question is, again, a practical question to this, and can we access it? And the straightforward answer is yes. We really do have all the technology today that we need to go grab these things and push them to the moon using the new ion propulsion systems. And if you've listened to some of the stuff, we also have the perfect landing vehicle. The Blue Moon fits right into my plan perfectly. You know, it goes from lunar orbit down, comes back. So here we go. Source of the hardware. This is 2016 data I grabbed. The numbers that stick in my head are 4,558 known abandoned satellites in 2016. So there's more of them now. And if you see the arc, the circle out there, that is not the geostationary arc. That's just beyond the geostationary arc. The geosynchronous orbit is at 22,236 miles above mean sea level. And that's the radius that one orbit of the Earth is exactly 24 hours. And oh, by the way, the Earth just turned to match that in 24 hours. So that's your direct TV dish points to the same spot in the sky because you're doing this together. Once the satellite has consumed its fuel, had some major problem, you then push it out to make room for somebody else to come use that slot. And I call it the graveyard orbit. Somebody else told me that wasn't correct. It's about 500 miles, and again, part of it depends on how much fuel you've saved and stuff. But they're out there. We empty the tanks, we turn the power off, we basically make them into a big lump, and they just float out there, and they oscillate. The Earth, the Sun, and the Moon have a way of screwing up the perfect orbit, so they start to oscillate. But they're there. So ownership and salvage. And again, this one, we have rules for salvaging ships at sea. Over the hundreds of years that we've had this problem, somebody goes on the rocks, the owner has the right to go try to salvage it, get the goodies out of it, to try to fix it if he can. If he doesn't at some point, it's declared an abandoned vessel, and anybody can come lay claim to that and start salvaging it. We have no examples that I know of where anybody's tried to do that with space. We certainly have several programs that I am aware of, saw the satellites, where we grabbed them with the shuttle, brought them back, refurbished them, and launched them. There's another program very near and dear to me where we actually captured a satellite, put a new solid motor on it, and sent it on up. We'll get to that in a few minutes here. So my hope out of this conference and anything that might lead from this is that we can really address this question on an international basis. We can start the discussion. There will be salvaging in space, I believe. And if we don't start its discussion and do this on an international forum, I think we're going to have a problem. So we need to establish some rules. We need to make sure that the international group can do this. So that's one of the things I hope out of this. So who's going to get called to this first conference? The spacefaring nations or anybody else who wants to join the club. 7 nations have orbited the moon, 4 have touched down. Very recently, the Israelis joined the team. Congratulations. Their landing wasn't quite what they planned, but then if you look back, almost none of the first landings were what we planned. So there's a nation who has, I think, officially announced they plan to put humans on the moon soon, next year or soon. And again, I've been in the industry a long time. We've talked about, from the Apollo program, we talked about building the base and not just going up for the weekend, but actually, going up to stay. I believe firmly in the next decade, we really will start establishing a base on the moon, permanent presence. So who's going to do all this? And I think those of you who have been at the conference here, the answer is the initial thing is going to come from private industry. The government talks a good story. I love the government. They take forever to do anything. And so I think the push is going to come from Jeff and from Elon and others who are going to be part of this. U.S. government's going to be a player. They just announced again their plans to go to the moon. That's good. I like that. ESA, the European teams, amazing talent, amazing things they've done in space. Russia, maybe a player in this, maybe. China certainly is going to be a big player in this. India has some potential. India has done some remarkable things. I'm just very happy for what they've done with their polar launch vehicle and stuff. Israel is now in the game, and there are lots of others. Brazil, you can name others. So again, in the high bay, in the clean room, we assemble and test the satellites. And the 1,000 satellites up there have to be 1,000 different configurations because we never make them the same, which is why we keep the price so high. Here's a typical communication satellite. And again, you start with the launch vehicle, and it comes up to an adapter. You have a certain diameter at the top of that adapter. The spacecraft then fits on that cylinder, that ring, and we clamp it. And when we get to where we want to kick it off, we pop the clamp off, some springs, and off you go. So that clamp, that ring, is what you see attached to the bottom of that cylinder. That's the main spine of the spacecraft. We then put a series of horizontal decks, and then we build a box around it. And all of the equipment then gets put inside that box, and it gets jammed in that box so tight. We have brackets and struts, and we put it all in there. The bottom part we call the bus, drives us up there. It typically has the propulsion equipment, the reaction wheels, momentum wheels, the computer, the controller, a lot of other housekeeping sort of things that we have to do. The batteries are down there. And then the whole top part is the money part. That's where the payload's at. That's where your broadband system, DirecTV, all that stuff goes. And I don't have a laser to point, but if you look at the side closest to you, the white side, those are mirrors. They're little tiny special optical solar reflectors, OSRs, and they're there for thermal reasons, because as you go through the seasons, you have direct sun. One side of the satellite gets too hot, the other side too cold. So we put the mirrors on to help do that. So those are called OSRs. The porthole there at the bottom on the upper piece, that's where the solar wing comes out. The solar array comes out. It turns 1 revolution per day to track the sun. So the mirrors we're going to talk about again, the central tube we're going to talk about, the panels and stuff. Here's another view. One of the things that's very critical in my thoughts are the tanks. Classic communication satellite, other satellites. Inside that central cylinder is where we put the propellant tanks. A classic design is a bipropellant. You have an oxidizer and a fuel. Those are expensive, super lightweight, designed to zero margin, titanium tanks. And again, once you start building your base on the moon, I think you're going to need some tanks. So then back to where I started a little earlier. Somebody asked me, are you just going to get little pieces and take them to the moon? The answer is no, we're going to take big pieces. And so how big is big? At the time, in 1990, the biggest commercial satellite was the Intelsat 6. And Hughes Communications built 5 of those for Intelsat Corporation. The launch mass was right at 10,000 pounds, and it was kind of $100 million to launch the sucker. And so there's my $10,000 a pound again. One of these, Intelsat 603, was stranded. There was a mistake of pilot error. We ended up abandoning the kick motor and stranded the satellite in low Earth orbit. And there was a lot of discussion, do we burn it up? What do we do with it? I argued strongly, we can save it, we can do that. We ended up hiring NASA to go rescue our satellite. And the original plan was, and I was involved, I was Intelsat's technical lead on this. So I was in Houston, we kept practicing how we grabbed the satellite. Some more pilot error, we didn't grab the satellite with the plan that we had. And so 3 of the astronauts went out and literally grabbed it. We brought the shuttle up under it. I was the guy who wrote the instructions on how they do that, because how you reach out, how slowly you stop it, what do you do, it worked fine. So it was a big day for me. Oh, there it is right there. So this is what the Intelsat 6 looks like, and that's what I looked like a long, long time ago. It's a very large satellite, again, at the time, and this was prior to the central cylinder concept. This was a dual spin. So part of it spun to give you stability, and then the solar panels, rather than being flat, are circle because you're doing that. There are 5 of these. The one we rescued went on to GEO. We made a lot of money off it, so it worked out very well. NASA lost some money, I think. 5 steps. I'm probably way behind time here. Pick, park, disassemble, catalog, deliver. Pick is the easy part. You decide which one you want first. Decide your target. Make sure you understand that you've got an interface ring that you can access. Make sure you understand it's not covered with blankets or the things aren't deployed in front of it. Then you have to pick a space tug. And again, this is part of the story. We don't have a space tug today, but numerous people are designing, building space tugs. There's a whole plan to refuel, refurbish satellites. Every one of those has a concept for a space tug. By the time we're ready to do this, there are going to be numerous space tugs. Whether you call, spaced Uber or who, I don't know who you call, but we'll get us a space tug. So you grab it. The space tugs will have replenishable ion propulsion motors. And so you just slap on another big module of xenon and off you go again. It will happen. We will have them. And then you just grab your spacecraft and head for the moon. There have been quite a few people studying transfer orbits from GEO to the moon, so it's just time. Once you get the spacecraft, you get it to lunar orbit, you pick your orbit, you disconnect it, and it's there. It's still turned off, it's still dead, but it's there. Then you return the tug and do the iteration, repeat, and boom, you're off. Steps 3, 4, and 5. Steps 1 and 2 we can do whenever we get a space tug and somebody's ready to put some money on the table. Steps 3, 4, and 5 will wait until there's an actual demand. We're not going to spend time, resources to start getting these things ready to go to the lunar surface until we're ready to use them on the lunar surface. But they can float in the lunar orbit as long as we need them. I haven't attempted to think through the financial part. Clearly somebody's got to put a lot of money up, but there really is a lot of money to be paid. I mean, people are going to want the stuff that's up there. Disassemble. This one is tricky. Again, I was involved when the astronauts went out and manually did stuff. Space station, they've done numerous spacewalks, repairs. We can do that. It's dangerous. It's going to require, there's going to have to be a space hab. We're going to have to get one of the commercially available space habs, put it in lunar orbit so the astronauts have some place to work from. When we launch a satellite, we have it all folded up neatly and it fits right inside the fairing with only inches to spare. Fairing comes off, we go up, we start deploying things. The solar arrays go out forever now. We have deployable reflectors that are 40 feet in diameter. 40 feet kind of goes from over there to over there. Those things are going to have to be dealt with. We're going to have to take up a little motor and drive the deployable things back. We may have to disconnect and take the solar wings off, cut the cables and fold it. I haven't solved all those problems. We have to do some processing, but it can be done. And again, most of these things, especially the ones that are still a box, and they were talking about GOES at one of the other things this morning. The GOES satellite, it would be very simple to grab. It's got a much smaller solar array. It doesn't have any large things. So each one of these is going to be different. I say catalog. This is Amazon's business knowledge area. You basically have to keep track of everything you take off so that your facility can find it quickly and do it. And again, we have the technology. We're doing it a lot. There's a buried question in there, and that is, does the guy who built the satellite get involved in this? Because he's the guy with the records. And again, that hasn't been addressed yet. It would seem that there's a benefit for everybody. He has the records, he gets half the money. I don't know. So everything has a code to it, everything gets scanned. We have part numbers and traceability and qualification numbers all the way down to the smallest washer. We know exactly what we put up there and we know where it's at. Delivering it. Again, it can stay in lunar orbit until we're ready to use it. The blue moon, I love it. The big frame on top that we can tie stuff to. We can either start taking stuff apart and take some to the lunar surface when we're ready. All of that will get worked out. So then the question is, what did we just get? What did we get in this thing that we moved over there? And the answer is, on day one, you're going to need power. We have solar arrays. Yes, they were designed for 15 years. Yes, we're past. But if you, again, the curve goes like this, and then it goes like that. And so you still have generation area under the curve way out there. The same is true with the batteries. I was with ComSat for 20 years. We had a battery lab. We had some batteries on the test stand for over 30 years, and they were still working. So back to my tanks. Liquid, gas, you're going to need tanks. And I just can't imagine shipping 20 giant tanks up using your whole payload capability. You got tanks up there. You got tanks of every size and shape. You can clean them easily. You just let vacuum clean them. We got all the propulsion hardware. We got the lines, the valves. We can put our tank farm together very quickly. Copper wire. We have miles of copper wire, big bundles, 8 gauge, 12 gauge, you name it, we've got it. It can be used as is, just cut the clips off, put it back on the spool, wait for it, or you can strip it. All of this is designed to be stripped, so you can use that. Things like stepper motors, we use them to guide the antennas. They step all the time, 24 hours a day for 15 years. They can now steer the antennas that we want to point back toward Earth. I was thinking this morning about heat pipes. We have heat pipes to conduct hot to cold. We'll come back to that in a minute here. So direct repurposing. For those of you old enough to remember E.T., first thing E.T. said was, what do you have to do? Phone home. So here we have the communication hardware in every C-band, K-band, Ku-band, Ka-band, X-band, S-band. We got everything you could possibly want. We got the full antenna systems. We got the receiver, the transmitters. We can phone home. And it can be used just directly. I mean, literally. Solar arrays and batteries, we talked about. The mining on the moon. And again, I heard another presentation. When we have 3 million people in space, we are going to have to do this. We're going to have to find real-time resources. But 3 million people and mining on the moon is a long ways away, in my opinion. The one thing we're going to mine instantly is we're going to mine water. We need to go extract water. You have to do that. As soon as you extract it, you need someplace to put it, tanks. So, but the cost of transferring mining equipment to the moon, first of all, to do the exploration, to do the test bores, not going to happen. Better idea is to use the metals that we've just captured and refine those. And again, 20 years ago, we weren't talking about 3D printing. Now I think, I'm a structures guy, not a 3D printing materials guy. I think it's within our reach to be able to reprocess this, make the powder for make the wire for the 3D wire technology. It just makes so much more sense to me. And again, I overuse the term tons, but we really have tons of this equipment. I mean, this material we can use. Again, my mind goes way. We can use the bits and pieces, or we can decompose them and take them back to their initial state. And again, the powder processing or now wire. I met a guy here who's 3D printing rockets using 3D wire technology. Wow. So the aerospace material, for those of you, if there are any of you mechanical guys in the audience, we have all the stuff that we always use. Aluminum 2024, 6061. If you need a high strength, you go to 7075. One of the benefits on the moon is you don't have to design this thing to be so dang strong, because you're not going to launch it on a rocket and you got 1/6 the gravity. So we'll have lots of strength margin. Stainless steels, the titanium, the high temperature metals, we'll have a lot of rocket motors that we may be able to use directly, or we can reprocess those high strength, very expensive metals to do things. And again, copper, there's actually silver inside a lot of the waveguides when we need extra performance, and it's fairly simple to reverse the electrolysis and take the silver. So you got maybe not tons of silver, but you got a few pounds. Structures engineers love struts, they love trusses, they love building things. There are so many struts. When I think of the satellites that I've been involved in the last 50 years, we have little struts, middle-sized struts, big struts. All of this stuff, you just take the bolts out of the end and you got a strut. And again, with all the AI that we've talked about, I can envision the designer sits down and puts a concept and then punches the AI button that says, given what I have in stores, how best can you build me something that looks like that? Give me 3 options. Bang, bang, bang. You put the bolts back in, you got your struts. You're going to need special end fittings. I 3D print what I want. I can build anything, literally, overnight. I'm going to run out of time here on you guys. Things that a truss might do, you can build things, support the tank farm, mount the antennas. So here, back to Amazon, I just used the panels that I just took off. I used my struts to build me a little truss setup. I got storage racks. The central cylinders, these are very unique, very large. You probably can go to what we call chopped graphite and then add new resin and mold them into things, or you can get crazy and just use them as central cylinders, as cylinders. And again, the bottom of the cylinder attaches to a ring. The top of the cylinder has a bolt pattern. I set one upright. I turn this one, the bolts tie. Now I've got a ring sticking up there. I set the next one on the ring. I clamp. I can build whatever you want. And fasteners. We're never going to have to ship fasteners to the moon. Not for a long, long time. We have to insulate the spacecraft, and we do that with MLI. And again, on the Earth, we call it space blankets. We take usually a Kapton, we put an aluminized surface on it, we put some spacers between it. It does 2 things. It provides thermal protection and it provides micrometeoroid protection. All of this stuff obviously started in flat pattern. I can undo the Velcro and the tape, and I got my flat pattern. I can envision making a quilt. Rather than 10-layer MLI, I have 50-layer MLI. I got blankets. Wiring, we talked about, we got all that stuff. My thought is that we're going to recycle everything. There aren't going to be any city dumps on the moon. We're not going to start piling crap in the corner. There things that we can't use immediately, we can compress. I was just the judge at the California State Science Fair, and a young lady from 8th grade had taken plastic trash, found the right temperature, the right pressure. She made little blocks. And oh, by the way, you can use them to make planters or whatever. We can do a similar thing. We can put things of like stuff together, and 10 years from now, we may want the material that we use to make Velcro, and now we know where it's at, and it's not. Anyway, we'll do that. Now I am out of time. Not on day one. There are lots of things that we can use. Back to my OSRs. This is the facility in France. It's been going a long time. So rather than have a mirror that you move, you build the big mirror and you move the focal point. And we can get 20 suns in a hurry. We can melt anything. Pardon? I'm out of time. So let me show you that. South Pole, we talked about, that's the right place. South Pole is where you get some daylight, we can use these mirrored things to direct and use it for light. There's what I had in mind. We have failures. We can now tell what the real failure was because we can take the stuff home. And if we're going to go to Mars and stuff, we need to understand. Okay, I'm going to finish. Anyway, I'm going to stay around. If you guys, anybody has any questions, I'd be glad to answer them.